Good. Welcome back to the world of calculus. Now, we want to focus on alphabetical and numerical expression together. Okay? And what we are going to start with is what we end with, which is the real number system. We have the real numbers we have done here, but now let's look at some systems, some properties, and look at some examples. Of course, we have a lot of them. We have exponential, distributive, periodical, and modulo, and the number system and the complex number. So let's start with real number system. So good. Now let us look at the properties. Some people call it axioms, the rules, the regulations of number system. Real number system. The first one is closure. What do you mean by closure? Closure properties. Let me just say closure. Closure property. Closure property in real numbers. These are numbers when you have two real numbers together, and the result of the right answer, the number of the right answer produce the result in the left answer. This is a closure. So, for example, if we have a property x plus y, of course, this is x should be real number, y should be real number. That is, x and y belong to real numbers. So any real number can work. So this is closure if you find the sum of two. For example, we have 2 plus 8. 2 plus 8 is what? 10. 2 is real number. 8 is real number. And the result we produce is also real number. This is closure. This is closure. It can also do the same thing for multiplicative. That is, x, y belongs also to real number. So if you multiply the number 2 by 8, you will lose 16. So this is also closure. Let's quickly move to the second property. The second property is called commutative property. Commutative property. Okay, let me just write the property. Commutative. What is commutative? A good example of commutative is beans plus rice plus beans, everything put to the stomach. Alright? So you can say x plus y is the same thing as y plus x. If I like, I can put x first or put y first. It's the same. It can also be the same thing for multiplication. X times y is same as y times x. I will get the same result. So a good example, let's say we have 2 plus 8. 8 plus 2. All of them is 10. So no matter the arrangement, is the same. So which means addition and then multiplication, they are multiplicative, commutative. They are commutative. So we can also say, for example, 2 times 8 is the same as 8 times 2, which is 16. So anyone I arrange, I get the same result. It's called commutative. We also have what's called associative property. Association, right? Associative property. Associative deal with 3 numbers, 3 letters. You can see why we call it alphanumeric. We are using both number and letter. So if you have x plus y plus z, it's the same thing. If I like, I can operate this guy first before this, or I can say x plus y plus z. I can operate this guy first. I will get the same result. If it's multiplication, you can say x, y, z. Multiply this first. X, y, z. Multiply this first. I will get the same result. If I like, I do this one first, and this one first, and this, I will get the same result. So let's just check some results, some questions. Let's say we have 3 plus 2 plus 7. I do this one first. It should be the same with 3 plus 2 plus 7. I do this one first. Let's do it. So, brackets, bottomless, right? Bracket first. So, 3 plus 2 is 5 plus 7. And 5 plus 7 is 12. want to check whether this guy is also the same. This is 3. Board mass, we have to add this one first. 2 plus 7 is 14. Sorry, 2 plus 7 is 9. I'm mistaken, right? This is not multiplication. This is addition. 9. So 3 plus 9 is 12. So you can see that this is equal. So any arrangement is okay. So let us do the multiplication now. So if you have 3 times 2, 3 times 2 times 7 is the same thing as if I do this one first, or 3 times 2 times 7. I can do this one first. I should get the same. So 3 by 2 is 6 times 7. I should be the same. It should be the same thing with 2 times 7 is what? 14. So the result I will give me here should be the same result. So let's check it. 6 times 7 is what? 42, right? 42. And now 3 times 14 is also what? 42. So you see, it's equal. Which means addition and then multiplication, they are also associative. They are commutative, they are associative. The next property is called additive inverse. Additive inverse. Or before that, let us look at additive identity. Identity. What is identity? So let's make it. We have 2, so let's use the word identity. Now we have 2. We have additive and we have multiplicative. Additive, multiplicative. For the additive, that is, anything we had with a number must give us the same result. Example, x plus 0 is 0 plus x is what? Is x. Nothing changed. If you say 7 plus 0, or you say 0 plus 7 is 7, nothing changed. It's called additive. So the additive of the identity additive is what? It's 0. No matter what you had to the 0 is that number or that letter. Nothing changed. We also have multiplicative. That is, anything you multiply with a number will produce the same thing, which is what? X times 1, or 1 times x, which is what? X. So anything you multiply by 1 must give you the same. Identity for additive is what? Is 0. Identity for multiplicative is what? 1. I hope you are following. This is very important. No matter what you had with 0, we give you that number. No matter what you multiply with 0, with 1, must produce that the same. Number 5. Inverse. Inverse property also have 2 ways. We have addition of it, and we have multiplicative. For the addition, when we say inverse, it's like you find the reciprocal, right? But for addition, if you have x, the inverse of x, this is plus x, right? The inverse of plus x is what? Minus x. So, plus its inverse, it must give you 0. This is x. The inverse of plus x is what? Minus x, which must produce what? 0. So if you have 2 plus its inverse minus 2, it must be what? 0. Even let us work with fraction. If you have 7, so the inverse is what? Minus 7. But let's do 1 over 7. Over 7. Inverse is what? So it can be, since it's a real number, it can be fraction, it can be decimal, it can be any number. Once it's within the value of real number, this property, it works. for multiplicative, don't forget, when we are doing multiplication of numbers, if you want to find multiplication, if you have division, you have to find the reciprocal, right? Exactly. So if you have x, the inverse of x will be what? 1 over x. What is it? If it is x, so multiply by its inverse is going to be what? 1. You see? For the 0, for the x is 1. So if you have, for example, 3, so multiply by its inverse, that is multiply by 1, is what? 1. If you have 7 over 2, 7 over 2, the inverse of 7 over 2 is 2 over 7. Right? So if you multiply it, you will get what? This is very nice property. We have another one. It's called distributive property. Distributive property. Let's call it number 6. Distributive property or distribution. Distribution property also have addition and also have multiplication. But this one, it takes 2 operations together. We have left and we have right. We have left distribution and we have right distribution. That is, if you have x multiplied by let's say y plus z. Of course, x, y, z must belong to the real number. Any real number works. And don't forget, we have a lot of numbers. We have looked at it. Rational, irrational, whole number, natural number. So this guy is the same thing as x times y plus x times z. So let me construct. You can say y, let's see, write it as x plus y times z. So you can multiply for the back. It doesn't matter. So we have x z plus y z. So whether you put it in front or you put it in front. So you see we are having 2 operations. We are having 2 operations. We have multiplication and we have addition. So you can see that addition and subtraction, sorry, not subtraction. So subtraction and division, they are not commutative. They are not commutative. Should we prove it? X minus y. Is it the same thing as y minus x? No. Let's take the value. Let's say x is 1. Y is 2. This is 2 minus 1. 1 minus 2 is what? Minus 1. But 2 minus 1 is what? 1. You see? Subtraction are not commutative, are not associative. They don't have identity. Inverse, distributive. Good. Now let's look at some examples to play around with these properties. Good. So let's put together all what we have been learning. We have length, brackets, index, multiplication, division, addition, subtraction. Okay, let's put all of them together. Let's solve it. Ready? Don't be panic. Let's follow the board marks or bit marks. So follow the board marks, bracket first. So that will deal with the bracket first. Inside this bracket, we have another bracket inside. So first, go inside there and deal with it. Let's go. So we have 0.125 divided by 1 whole number over 3 plus this one is what? 1 squared. So let me look at it. We'll do this one first. 1 squared is 1. 4 squared is 16. Right? Minus 0.1211. Divided by. Okay, we are still inside here. Now, addition, right? If you have to add this and this guy. But in order to add this guy and this guy, you need to specify this is very big number. This is a decimal number. Remember? This is mixed number. whole number and the proper fraction. You know? So we are putting everything together. So convert 0.125 to fraction. What do we have? We have 125 divided by 1,000. And this is what can change it to improper fraction. This time this plus this is 4/3. Plus 1/16 minus 0. Leave this one for now. We are not here yet. Now this is division. We have a lot of division here. Be careful. So we are still working on this. Come here. We have now 125/1000 divided by 4/3 plus 1/16 minus 0.1211 divided by 73/4. Now we are still inside here. This is multiplication. This is division. I can change to multiplication by finding the reciprocated. In French, what is called this? Okay. Now change it. We have 125/1000 times 3/4 plus 16. That means 1/6/16 minus 0.1211 plus divide. Good. We can do some operation here. We can multiply. Possible. We can reduce it. I think we can reduce it. 185. 125 goes here 1. 125 here. 1, 2, like 8. I think that would be 8. That would be 8. So if you multiply this by 8, it should give us 1,000. Right? So what is left now is 1/8 times 3/4. We can just do that one directly. So 1 times 3 is 3. 8 times 4 is 32. Plus 16. 1/16 minus 0.1211 divided by 73/4. Now you see we are getting smaller now. Getting smaller. We are still inside the bracket. Addition before addition before subtraction. Both max and a. So add this one together. What is common factor here? This place. Common factor 16 can go there. Right? 2 times. So we can say 32, this and this, 1, this, 3. 16 and 32 is 2. 2 times 1 is 2 minus 0.1211 divided by 73/4,000. Okay. Very interesting, right? Now, this is give us what? 5/32 minus 0.1211 73/4. Without wasting much of our time, we can just use our calculator to divide this guy by this guy. Right? Divide 5 because this is fraction. I want to already do fraction so that we can just convert it. Okay? So divide this guy by this guy. 5 divided by 32. That is what? That will be 0 point something. 0.15, yes, 625. Good. Minus 0.1211 divided by 73/4. Now minus this one, just to make life easy, that's why. Minus this one, how many numbers here? 5. So let's just do this element for time. 1, 5, 6, 2, 5. Or you want this calculator? Of course you can use calculator. So this is 5, this is 1, this is 5, this is 3, this is 0, and this is 0. So we have this one. We are still inside the brackets. Now finally bracket is finished. This is 0.035515. Now divided by 73 over 4,000. If you like, convert this one also, but if you don't want, let us convert this one back to fraction so that they look the same. They look the same. In that we have 3515 divided by 1, 2, 3, 4, 5. So we have 5 zeros. 1, 2, 3, 4, 5. Divided by 73 over 4. Now we convert the fraction. Division, reciprocal. We have 3515 divided by 100,000 times 4 over 70. By the way, this one can go here, right? Reduce it. Reduce it. Okay, this is 1, 2, 3. 3 zeros. 1, 2, 3. 1, 2, 3. So what is left is 3515 times 4 divided by this and this 100 times 70. Interesting. 5 can go here. 5 go here is 20. 5 in 37 is 7. It's 5. It's 7. Yes, I'm right. 7. Very consistent. 5 in 1, 0. 5 in 15 is 3. Good. So what is left? Okay, 4 can go. 4 goes here, 1. 4 goes here, 5. What again? Now we have here 703 divided by what we have here? 5 times 5. 73 times 5 is 15, right? We have 1 left, 35 is 6. That is 365. This guy, the neck is spelling this guy. So change it to mixed number. How many times this one goes here? Let's check it. 703 minus 365. So we have to borrow 1 here, it will be 6. Borrow 1 here, it will be 9, which is 13. So this is 8. 13 minus 5 is 8. This is 6. 6 minus 1 is 3. This is 1, 3. So that moves too much of our time. The final result will be 1 whole number 338 divided by 365. Then you welcome. So this big number has been reduced to this number. And this is the right place to stop for this big number system. Okay? Let's go and take coffee.